All right, so we are going to go over the 11 questions from yesterday for starters. So let's start with number 1, and that was e raised to the secant x over cosine cotangent dx. All right, so we got a mess of a problem here to start with. Hopefully your first instinct was we should probably be doing a U-substitution here, right? So you go off to the side, we're going to make a box, and we're going to go with U du dx. And remember the advice I gave you, not always is it going to work, but more times than not, U is going to be the stuff in parentheses, the stuff under the square root, the stuff with the trig function in the parentheses, or the thing that e is raised to. So in this case, we're looking at the thing that e is raised to. So we're going to go with u being equal to secant x. And then we just started talking about all 6 trig functions. Now we got to, as you see, we got to know them. So the derivative of secant is secant tangent. And we want to tack on our dx after that. So it's secant x tangent x dx. And then if we solve for dx, it's going to be du over secant x tangent x. Okay, so then we're going to go start to plug some stuff in and see what happens. So if we do that, we're going to come over here. Now we've got e to the u cosine cotangent du over secant tangent. And then this would be the point where I would assume lots of us got to this part and now we hit a roadblock because every other problem we did, stuff started to cancel and it was cool. That's still the case, but we need to recognize something in order for stuff to cancel and it to be cool. Anybody know what we got to recognize or what do we have to do to make this happen?
So the secant of x is the inverse of cosine. So first we like take du out of them. We're gonna take like 1 over secant x over times tan of x, and then 1 over secant of x is cosine of x, and 1 over tangent of x is cotangent of x. So
Yeah, so there's 2 ways of looking at it. You can do exactly what he just said, which is work with this, or you can forget about that and work with this. So somewhere or other, let's go off to the side and do a little bit of side lesson here. If I tell you, let's list our 6 trig functions: sine, cosine, tangent. Everybody knows those, right? Okay, then after sine, the inverse of sine, inverse, is cosecant. The inverse of cosine is secant. The inverse of tangent is cotangent. What do we mean by inverses? 1 over. So like if I tell you this, if I tell you sine, it's the same thing as 1 over cosecant. Okay, translation in English. If you bring this upstairs, it becomes its reciprocal. If you slide something from upstairs to downstairs, downstairs to upstairs, whatever, if you move it, say for example, we have this cosecant x over 5. If I want to bring this downstairs, no problem. When you move it, it just becomes its reciprocal. So in terms of trig functions, if you move one from upstairs to downstairs or downstairs to upstairs, numerator, denominator, it just becomes its reciprocal. And this is your list. Those are your reciprocals. So when we go back to where we were at, doesn't matter which one of these you grab, but 2 of them we got to move upstairs. So whether I want to move these both upstairs or these both upstairs, doesn't matter. I have more room on my paper over here, so I'm just going to flip these. So I'm going to flip these upstairs. If I bring secant upstairs, it becomes cosine. If I bring tangent upstairs, it becomes cotangent. So these are now gone. I brought them upstairs as their reciprocal. And now we're back to, okay, nice. These cancel and we can finish the problem. Any questions on that? Okay, so now cancel, cancel. And now you should be home free. So now you want to just integrate e to the u du. Did this problem have any bounds on it? Did I miscopy anything, or was it a plus C problem?
No, it's unbound.
Okay. All right, so if you integrate e to the u, that's just e to the u plus c because it's indefinite. And then we just finished the problem by plugging it back in, e to the secant x plus c. Everybody good? Okay, taking us then to number 2, should be a lot quicker. Number 2 is integral of 4x to the third, fifth root of 3 minus 6x to the fourth dx. All right, so for number 2, there we go. It's also a U-substitution. Hopefully you're starting off with the stuff under the radical. So you're going to go with u du dx. So u is going to be 3 minus 6x4. It's going to make du negative 24x to the third dx. It's going to make dx equal to du over negative 24x to the third. And then we're going to take that stuff, come on over here and toss it in. So this is 4x to the third, u to the 1/5, because we're doing fifth root, du over negative 24x to the third. This looks a whole lot like the kind of problems we've seen on our test. So hopefully everybody's cool with cancel, and we're going to take out 1/6, negative 1/6 to be more accurate. So this is negative 1/6 u to the 5th du. We still got to integrate, but now we've got everything set up so that we could do that. So let me pause for a second, give everybody a chance to catch up if I was going too fast. So I'm just going to leave that there for about 10-15 seconds. Leila, did you need to do U-substitution for this one, I hope?
Yeah.
Okay. All right, so let's integrate this, and this would be u to the 6/5 over 6/5. That's add 1 to the power, divide by the power. We've got a negative 1/6 out front. We've got a plus c. We've got an answer. We just need to clean it up now. So divide by a fraction means we got to flip this. So it's coming up as 5/6. So if we change this, I'm just going to bring it as 5/6. You can start to see that it's going to be negative 5. We're going to have a 36 on the bottom. I'm going to plug back in for u. I've got 6/5 plus c, and then we just need to drop in our substitution of 3 minus 6x to the 4th, and you've got it. Any questions on number 2?
Yeah, wouldn't the 5 actually, because if you put, let's say, over 1 underneath the 5, wouldn't that mean that the 5 and 6 would then be multiplied together?
Say that again.
So
what line am I on here? Here or lower?
Lower.
Lower.
Right there. So wouldn't it be, and then it would be over, I got there, over 6/5, and then from there it would be, oh wait, no, never mind.
Did you answer?
Never mind.
Did you answer your question?
Yes.
Okay, cool. Any other problems, thoughts, comments on number 2? All right, takes us to number 3. Let's see what we got. All right, 3 is easy, but there's a little trick to it. So we never saw one like this before. So this is a lot of what we're going to be doing in the second half, guys, is just learning on the fly. So you should be able to see this, and then once you see the trick, you'll say, oh, okay, easy enough. So what's the problem with this problem? What do we need to do?
figure out what U is?
So this is actually not a U-substitution problem.
You've got to bring the X up from the bottom.
No, you
We
have to like separate them and then cancel them out. It's gonna give you extra.
Yeah, so check this out. So think about this. Let's go over here and do a little algebra. Forget the integral stuff. If I told you this, if I say A plus B over C, isn't that the same thing as A over C plus B over C?
Yeah.
So if you take that idea and you apply it here, this is the same thing as x to the fourth over x plus x to the third over x plus 5 over x. And then if we do a little more, that's really x to the third plus x squared plus 5 over x. And that is what we're trying to integrate. So if you just have a singular x on the bottom, we can split everything up and just toss each one over x. And now you can just go through and you integrate. So if we integrate this, what do we get? X to the fourth over 4 plus x to the third over 3 plus, what's the story now?
This is the tricky part because it's, if you bring x up, it's gonna give you like the denominator of
Negative 1, then you add 1 at 0. That's no good. What situation were we talking? Remember there was one before where that situation happened. What did we do to fix that?
Isn't it natural log?
Yeah, exactly. It was natural log. So let's just hold on to that idea and I'm going to come back to it. We'll be right back. So let's look at this now. If I tell you this, I think everybody's good with that, right? Okay, so first off, I need to make a little change to this because I kind of skipped over this in the actual school year. If you integrate 1 over x, you have to toss absolute value signs around your answer. This is, I don't think, going to be the difference between right and wrong, but it's in the multiple choice. You're going to see these absolute value signs given. The reasoning for this is when you backtrack into natural log is really log base e of x, and then it's like saying e to what power is equal to something. It can never be negative. It wouldn't come out with a negative answer. The absolute value sign is just like guaranteeing you a positive answer. I would just turn your brain off and accept it and memorize it and just know that when you integrate this little situation, just tack on absolute value symbols. All right, anyways, let's see what would happen now if I did this. If I tell you to integrate that, that's the same thing as this. How can we make it better though?
3 times 1 over x.
Yeah, if I couldn't I rewrite it like that? Something like that, and then in which case, you can go through and it's gonna be the same train of thought. So when you integrate that, just think of it as like this, 3 times 1 over x dx, something like that. So then your answer really just ends up becoming 3 natural log x plus c. So when that takes me over to here, and I was at this situation, I would just call this 5 natural log absolute value of x. So just a bunch of little tiny things, little lessons on the fly, nothing crazy. Any questions on number 3? So I wasn't expecting you guys to get all this. It's a bunch of little things you got to see. But once you see them again, shouldn't have a problem. Okay, let's take a look at number 4. All right, number 4. Okay, so you got to be careful with number 4 because now you're going to be tempted to do something based on what we just did in number 3, and you're not allowed to do that. So you can't, in other words, let's go back to my algebra lesson. If I tell you this, A over B plus C is not equal to, you can't just rip this apart. It's got to be a common denominator to make that fly, right? This is no good. So can't do that. So I can't rip these apart. So the only thing you can do here is a U substitution. So this would be U du dx. And there's no obvious choice here. So when you're not sure what you're picking, pick the thing with the highest power. Because when you take its derivative, you're going to drop the power, which hopefully lands us somehow to cancel stuff, right? So I'm going to say it's x squared minus 4. So then it's going to be 2x dx. So then it's going to be du over 2x.
Sorry. When I was doing this, I like rewrote it and said x and then parentheses x squared minus 4 to the power of -1. And then that's how I knew it was u.
Yes, I think you can get away. I think we'll try it that way in 1 second too. Let's see if we get the same answer. That doesn't sound bad though. Then did you do a U substitution with that?
Yes.
Okay, let's try it and see if we get the same answer. So based on this now, I've got x over u du over 2x. So now I'm going to cancel the x's and I've got a half out front. And now, not 1 over x, it's 1 over u. Notice now that I've got 1 over u du. Integrates the same way. What's the integral of 1 over u?
1.
What?
The natural log.
Natural log. Yes, it's the same exact. Yes, the same thing we just talked about. So 1 over x is going to be the same thing as 1 over u. It's just going to be, so now we've got half natural log of u plus c. And then the last thing we need to do is toss this in. So half natural log absolute value 2x minus 4 plus c. Who was I talking to?
Me.
Josie, did you get the same thing?
No.
All right. All right, well, hold on. Let me finish this. Give everybody a chance to copy. This one's definitely what we're trying to get to. So give everybody 1 second, and then we'll look at what you had said. So I think we can get the same answer that way as well. All right, Josie, let's see here. So you said you brought that up. So then that would have made this x squared minus 4 to the -1, right?
Mm-hmm.
All right, let's try that. So that would be x squared minus 4. And then that's going to be 2x dx, and that's going to be dx is du over 2x. So now we've got x. Oh, it's the same thing. Look, so this is just u to the -1 du over 2x. Cancel the x's, take out my half. So now this is half u to the -1 du. Did you get to there?
Yeah.
Okay, so here's the thing. You just can't do that, right? Because when you integrate that, I add 1 to the power, and that's just going to be the special case that we have to avoid. So all you need to do is flip that downstairs, and you've got it, right? So if I flip that downstairs, now this is half integral 1 over u du, and then when you integrate that, you're going to be at the same place we just got to.
Okay.
Cool. All right. Takes us to, what was somebody saying in chat here? The recording site, if you go to Canvas on the main page, I have all the login information for Bennett's recordings.
Yeah, I think he's asking like if I can't make one of the sessions.
Oh.
I'll I'm gonna be able to go to every single one, and like if for whatever reason I can't, I'll go to the 7:39 one unless somebody else wants to record it.
Sounds good. So if you can't make one of them, we'll figure it out for them, but
Yeah,
it sounds like
I can reach
you'll
out
be
to
good for,
somebody personally and figure it out.
sounds good.
In case you can't make it to the class, like someday in the future, that's
I gotcha. Yeah, if we have a problem like that, we'll figure it out in advance.
Okay.
All right, so now number 5, x squared sine x to the third dx. All right, hopefully no problems with this one. So we're just heading through U substitution. So this would be U du dx. U is going to be x to the third. So that's going to be 3x squared dx, which is going to be du over 3x squared. Toss this stuff in. You've got x squared sine u du over 3x squared. I think we can just hop through this real quick, right? The x squareds are there. We've got 1/3 integral sine u du. Careful when you integrate because you don't want to do all this stuff correctly, then screw up at the end. So anytime you're doing a trig derivative, you try to solve the riddle, the integral of f prime is equal to f. What do I put in here such that when I take its derivative, it'll take me back to what's inside the integral? So what do I need to take the derivative of to get sine? The derivative of cosine is negative sine. So if I want this to be a positive sine, I need to come up with a negative cosine as my result there. So now it's negative 1/3 cosine u plus c. Anybody with a question on number 5?
Would it be acceptable if we wrote negative cosine x to the third over 3?
Yeah, same thing, no problem. It would just be, I mean, if it's a fill in the blank, both are totally good. If it's multiple choice, only one of them is going to be there, but they both mean the same thing. All right, takes us to number 6. Okay, number 6 is going to be the integral. And now we've got some bounds, 2 to 7. And this is the square root of x plus 2 dx. So I'm going to still have you guys look for a u substitution here. So this is u du dx. So this is x plus 2. So this is just 1 dx. So dx is du. When we go with that in mind, this is u to the half du. And then when you integrate that, we're going to have u to the 3/2 divided by 3/2, but you've done enough of these at this point that hopefully you understand we're just going to make it 2/3. And this time we have bounds. So before we get to the bounds, we need to clean this up. And it's 2/3 x plus 2 to the 3/2 bounds 2 to 7. Okay. All right. With that, we got to do plug in the top minus plug in the bottom. So we've got our setup. Okay. We're plugging in the top. That makes 9. The square root of 9 is 3. 3 to the third is 27. And then we want 2/3 of 27, which is 18. Plug in the 2, we've got 4. The square root of 4 is 2. 2 to the third is 8. And then 8 times 2/3 is going to be 16/3. So then we need to clean that up a little bit. So this is really, if we're going to make it into thirds, 54/3 minus 16/3. And that should take us to 38/3. Okay. Any questions on 6? All right, 7. Number 7. Okay, find the area bounded. Area bounded. We've got 2 curves. We've got, oh, this is new actually. So you probably had some confusion with this. So I taught you this to an extent. So let's see, the first curve is x squared plus 11. And then the other curve is, I just minimized it. Is it 2? Is that what it was? Okay.
Yes.
Okay, so when I taught you area bounded, it was here's my curves, figure out which one's on the top, figure out which one's on the bottom, and then we applied the bounds to figure that out. This problem doesn't give you any bounds. So if they don't give you any bounds, that means these things intersect somewhere. And let's think about what these 2 graphs are, just off to the side. This is some sort of parabola shifted in the air 11 units. So if you start thinking about this, here's 11 all the way up there. That's something like that. This is a horizontal line. That's something like that. So hopefully you can just think out what's what here. Did I copy that right? It sounds weird.
Yes, this is.
Yeah, that's right.
Is that right? X squared plus 11. I want to say there's a typo in this problem. Yeah, there's a typo. That's supposed to be x squared. That's a typo. That's supposed to be x squared minus 11. Huh? I haven't had a typo in a while. All right, here's why. So
That they got infinity for an answer.
yeah. We got this problem had a typo. So let's go back through and let me try this again. So this is y equals, let's go with x squared minus 11, and over here, let's go with y equals 5. I'm just going to change this problem altogether on you guys. All right, and with that in mind, all right, so same type of problem, but again, we don't have any bounds given. So I want you to think about these 2 graphs. This is a parabola shifted 11 units down. So here's down 11, we'll say, and that would be your parabola, right? And then this is a horizontal line at 5, and then that would go like that. So what you're looking for to figure out your bounds in this problem, to find the area bounded between the functions, we're looking for the area that I'm shading. This is a real popular question on the AP exam, like highly likely you see it, which means my bounds that I'm looking for are the intersection points of these 2 graphs. So I'm looking for what are the bounds where these 2 things intersect at. That will give me this area bounded between them when we do some integration. So here's the story from now on. Area bounded. Did they give me bounds? If yes, use them. If not, set my 2 equations equal to each other and figure out where they intersect. So you want to say x squared minus 11 is equal to 5. So if I set them equal and solve, x is equal to 16. X is equal to, take the square root, plus or minus 4. So the visual over here is showing you what's going on. That's 4 and negative 4. Now we have bounds. And you have to kind of think which function's on the top. You kind of have to think through it. Which one's going to be on the top? Forget about all this excess here. Which one's going to be on the top? The horizontal line or the parabola?
The parabola.
So we got 2 functions. I made this one.
The line.
Oh wait, no, it'll be the line because it's
Okay,
on top.
exactly. So that makes sense that that one's on top. So the only other way this can go is, like, say you had an upside down parabola and then you had a horizontal line. If the parabola is like negative x squared and it flips upside down, then you're talking about something like that. But for this case here, I'm saying, okay, this one's on the top, that one's on, I just did that backwards. That one's on the top, that one's on the bottom. Does that make sense? Okay, so now that we've got that logic down, what's the plan to find that area? It's the integral of the top minus the integral of the bottom. And these are both going from -4 to 4. Okay, so you guys go from there, find me an answer. Remember I told you when you're doing area bounded, best suggestion, best idea is to smush these together and make one integral first. Go. Okay, so if we smush these together, we've got integral of, so this becomes -x squared. You're adding the 11 over. So I've got 16. Everybody good there? If we distribute that negative, right? So you'd have -x squared, negative, add that over. Okay, time to integrate. So that would be -x to the third over 3 plus 16x from -4 to 4. So if that integration checks out, you just need to do some general plugging in, see what we get. So it's going to be something minus something. This looks like it's going to be really ugly. Let's see what we get. If we put 4 in, that's going to be 64, -64 over 3 plus 64. And then when we put -4 in there, it's going to be negative is going to be a positive. So that's going to be 64 over 3 minus 64. So let's see what we got here when we do all that. Yeah, because that's ugly. So -64 over 3 plus, what would that be? 192 over 3. And then minus 64 over 3 minus 192 over 3. That's 128 over 3. Minus a minus is going to be a plus. This is super ugly. 256 over 3. Anybody? I actually remember that answer from last year. That is correct. So 256 over 3 is what you were looking for. Any questions there? All right, so now I'm looking at number 8. Given the areas below, so let's turn this to a screen share so we can talk. Okay, can you see the screen?
Yeah.
All right, so what are we looking at? 0 to 5 f of x. What do we got here? This is the graph of f of x. That's a good thing. So 0 to 5, make sure you pay attention to the bounds. That means they want the area from 0 to 5. So you want a square, a triangle, a triangle. Remember, things below the X are negative. So keep that in mind. So if I were you guys, I would make that a, just drawing some shapes here. That box is 2 by 1, which is 2. And then you've got a 1 by 1 triangle. So cut that in half for the area of a triangle. And then that last triangle is 2 by 3 is 6. Cut that in half is 3. It's underneath, so -3, coming up with -1/2 for part A. Okay. Part B, same problem, but we're just going -2 to 2. So all we're doing now is, so this part here is 2. So now you just need to do the triangle to the left. And then that would be what? 2 by 1 is 2. Cut it in half is 1. Stays positive. Don't forget it's above the X, so it stays positive. So -2 to 2, I'm coming up with an answer of 3. And is there a part C? Nope, that's it. Okay. Takes us to 9. This is just more substitution. So let me see what else is on this test here. 9 is substitution. 10 is substitution. 11 we need to talk about. So I think, is everybody good on 9? Just 3x squared plus 1 is your U, and you go through the problem? You should be good on substitution by this point. All right, let's go ahead and talk about 10 because that problem's a disaster. So we'll go through 10 and then 11. So, all right, 10 is the integral of -e to the cotangent x over sine squared x dx. So I would assume you're going to look at this and say that I need to do a U-substitution because nobody can rationally.
Mr. Baker,
Yes.
the problem did give bounds.
Oh, thank you. What are they?
Pi over 2 and pi over 4.
Hang on, you cut out. Say that one more time. It was pi over 2
Pi
on the
over
top.
2 and pi over 4.
Gotcha. Thanks. Pi over 2, pi over 4. Okay, we'll come back to those after we figure this out. So we need to do a U substitution. So there's our box. Okay, remember the hints. When in doubt, the stuff in parentheses, stuff under the radical, the stuff E is raised to. So that's what I'm going with. The stuff E is raised to. So to get this going, you got to know the derivative of cotangent. So these are still kind of new for us. So make sure we learn them, study them. The derivative of cotangent is negative cosecant squared. So negative cosecant squared x dx. Solve for dx, and we've got du over negative cosecant squared x. All right, tossing this in, you've got the integral -e to the u du over negative cosecant squared x. Okay, hopefully we've got an idea for this problem now based on what I taught you earlier. Whenever we were in that mess with the trig functions, we can look for reciprocals. So here's the first thing I would do just to make this easier. I see a negative sign on the top and a negative sign on the bottom. Let's go ahead and just cancel those out. Gone, gone. And then whichever one of these makes you happier to flip up, do that. But they're going to give you the other one, so it's going to give you a cancel. If I flip this upstairs, it's cosecant squared. Or if I flip that upstairs, it's sine squared. Doesn't matter. Somehow we just want to cancel this. So it's sine squared x is up there. And then that allows us to cancel. And now we've got something we're ready to work with. The integral of e to the u du gives us e to the u, what's u, cotangent x, and now we've got bounds. Pi over 2, pi over 4. Don't do all of this in your head. Don't feel bad about writing it out. Plug in the top minus plug in the bottom. Okay, so if you need to draw a unit circle, draw a unit circle. What are we looking for? Pi over 2, pi over 4. So at pi over 2, what do we got for an ordered pair? 0, 1, cosine, sine. How do we find tangent? Tangent is sine divided by cosine. That means cotangent is cosine divided by sine. That means cotangent at pi over 2 is 0. So this is now e to the 0 minus, now you better know that one. A tangent or a cotangent at a 45-degree angle is either 1 or -1. Quadrant 1, pi over 4, it's got to be positive. That's just 1. Final answer, 1 minus e. Any questions?
Wait, Mr. Baker?
Yes.
Wait. Where did the sine squared x go? Wait.
So it canceled with this over here. I flipped up the cosecant, and when you flip up the cosecant, it makes sine
Oh, it
squared.
cancels both of them.
Gives me
Okay.
cancel. Yeah, to make U substitution work, we somehow got to cancel out all those x's.
Okay, thank you.
Okay, so that was number 10. And then let's talk about number 11. 11's not bad. We just got to understand what they're asking. So for number 11, okay, we've got, let's see. Okay, we've got the integral of -2 to a x to the 5th dx. And it's asking us all the values of a where the answer at the end of this whole story is 0. That's saying after you integrate this and plug in the bounds, final answer 0. What are all the different things for a that can pull that off? So before we get into an answer, let's just integrate it. This would be x to the 6th over 6 from -2 to a. And we want to know all of the different answers for a that make this answer 0. So what's the first idea that pops into your mind?
1.
1.
I mean,
Why
not
1?
0. 0.
Yeah, 0. Okay, 0 is the first thing that pops in your mind. So let's try that. So you say, all right, I'm going to let this be 0. So that's going to be plug in the top. Got it. Minus. But when I plug in the bottom, we can just stop doing math right there, right? -2 to the 6th, that's 64. That's not going to be 0. Agree?
Yeah, 2.
All right, so 0 is out of the picture. All right, next, let's try 2. 2 would make sense, right? So let's try this as a 2 up there. So if we plug in the top, 2 to the 6th is 64 over 6 minus plug in the bottom, -2 to the 6th, 64 over 6. That checks out. That's going to be 0. So check. The number 2 is good. Anything else ringing a bell?
I think that's
-2.
-2. Now, here's how we can save some time. Let me teach you a lesson real quick idea. If I tell you the integral of whatever, d whatever, we integrate this. I got whatever. All right, here's my bottom bound is 5. If the top and bottom bound are the same thing, guaranteed your answer is 0 every time. If your bounds match, the answer's got to be 0. Why? An integral is the area under the curve. Here's my graph. If I tell you to find the area, this is the graph of f. If I tell you to find the area from 3 to 3, am I finding any area? Not going anywhere, right? So I didn't find anything. So the answer is 0. So in terms of integration, if your bounds are the same, 100% every time, the answer is 0. So without even doing any math, I know -2 is good. 0 was a reasonable guess. We tried that. It wasn't any good. And then tried the same exact number, the positive version or the opposite symbol version, and then that'll take you to an answer. Okay. All right, now you've seen 11 questions. Well, 10 of them, we skipped one, but you've seen most of what you did yesterday. Any questions? Do you feel better about that now, having seen them? A couple little twists, but not too bad, really? Okay, if that's all making sense, that means you're in a good place. All right, so tonight I'm gonna have you guys be doing the free response problems as some homework-ish. But before you do that, we're gonna spend about 5-10 minutes reading through these and seeing what we can come up with, and then we'll let you go. So let's all open up the assignment, or actually, hold on, let me share it, that'll make it easier. Okay, there we go. So here we go, and let's just read. All right, now, as a heads up, starting this, free response. This is I know I've said we've done some before, and we have a little bit, but this is really the beginning of free response. And free response is 50% of your AP score. And I have no idea how I'm going to teach this to you over Zoom, but we're going to try our best. It's going to take a lot of back and forth. You're going to have a lot of questions. That's totally okay, but you got to ask them. If it's just me talking, we're going to get into trouble. So you guys got to really have a lot of conversation with me on free response. There's like, I don't know, over 100 of these that we have to read and do between now and May. This one being like the first one. So there's a lot of free response we have to dig through to get you ready for May, which you can see why I was in a bit of a panic when they said they were going to cancel, they were going to end the first half of the school year on January 30th, because I was like, well, that's not even going to be close to enough time. But here we go. This is your first real free response question. I don't know what year. This is actually from a test, like 2014 or something. So take 10 seconds, read the question.
Is the 12 plus 13 a part? Oh, wait, no, never mind.
No. I used this thing as a test once upon a time. So this was just like questions 12-13 accounts as a free response would count as 2 questions. All right, so you read, honestly, it doesn't even matter what we're talking about. You just see it's a box with data. What are we talking about? T is cooling. Okay, so we're talking about temperature. Don't get caught up in all the words and the language. We'll come back to that later. Just get a brief idea of what they're talking about. Liquid is cooling. T is cooling. Here's a chart of temperatures at a period of time. Okay, moving on. Part A, get very familiar with part A. It's going to be on the AP exam. There's never been an AP exam that did not have this question on it. It's there every year. The first part is always approximate the value of something prime of something. So when we're talking about prime, I'm talking about a derivative. Key word, approximate, means we're just estimating it. How do you estimate a derivative? The derivative is a tangent slope. How can I estimate a tangent slope? Estimate. Say again?
Could you just try to get the slope between?
Yep, you got it. So for part A, you're not going to see that. Let me try this. For part A, you're just talking about slope. So I'm not going to go through these. I'm just giving you an idea of what they're asking, and I'm going to have you try your best. And then tomorrow, that's what we're going to be going over is this. All right, let's get into part B. All right, for part B, explain the meaning of this. It's an integral. What does an integral find? What does it tell you? What does it actually stand for? The integral, any integral stands for what?
The area under a curve.
Area under a curve, correct. But also, what other words have I used to explain this? The
total
Wait,
amount.
Sum?
Yeah, exactly. So area under a curve is accurate, but in terms of these word problems, it's some sort of total, some sort of amount. Total what? Well, you got to apply that to this problem. It's the total amount of, I'm not going into any of that, but think about it and explain it. It's a total amount of something based on the problem, and then use a trapezoidal estimate to calculate that value. So you're just approximating that total amount. And you're going to start to see as you do these free response problems, all of these little lessons pop up in them. So it basically takes every little lesson that we've done and they start to apply them all over the place. Part A is talking about derivatives and slopes. Part B is talking about a total amount and then do a Riemann sum to approximate it. So you should have no problem doing part B.
Mr. Baker,
Yeah.
On the, I also have it pulled up from Canvas, and it is different. The problem is different. In the part B of that problem says, explain the meaning of one, looks like 1/10, then the sign, and then 10 to 0 HT.
In part B or part C?
Oh, my bad. It's part C.
Okay, there you go. Part C is coming up next. Okay. Part C, using correct intervals. Explain the meaning of this. All right, you don't know what that is. I need to teach that to you. Hold on 1 second. And then use a left-hand Riemann sum with 4 intervals. You know how to do that. Left-hand Riemann sum, no problem. We know how to do that. And then is there a part D or is that the end of this? Okay, that's it. All right, pause, come back. All right, I gotta teach you this. Here's a formula. So like I said, lots of little things on the fly. Formula for average value. Value meaning anything. Average, whatever they're talking about. Average T, average temperature, average amount of water, average amount of bees in a hive. I'm trying to think about other problems they use in the AP exam that I've read over the years. Average, whatever they're talking about, is found by the following formula. 1 over b minus a times the result of the integral. 1 over b minus a times the result of that integral is the average value. So if I ask you to find, as a side example, let's do a real easy problem. I tell you, we'll talk about average value more throughout the week. If I tell you find the average value of that means to do the following. Does that line up? 1 over b minus a, 4 minus 1, times, then just go through and do your integral. I'll get into more of an explanation why this is what it is, but for right now, just know the formula. Average anything, average value is found by 1 over b minus a times the result of the integral. So we want that formula down. And then when we go back now and read, just know that when you see a fraction in front of an integral, we're probably talking about average value. So what does this mean? It's talking about the average amount of whatever they're talking about. The average temperature is what we're talking about, because this all stands for temperature. The average temperature of the thing over the period of time is what this stands for. And then use a left-hand Riemann sum to calculate it. Okay. Okay, so you're going to try that. And then we've got a second problem down below, 1415. Okay, ready? We're going to read this one. Hold on, can I show the formula again? Yes, the formula is right there. 1 over b minus a times the result of the integral. All right, next one. So we are going to start reading, and this one's called Jeff Jogs. Jeff jogs along a path, yada, 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 whatever. This is talking about velocity over a period of time. Velocity over a period of time. So this guy's moving, he's running, he's walking, he's whatever, and we're charting his speeds, his velocities over this period of time. So for part A should look super familiar. I promised you, you'll see it a lot. They love part A. Same thing goes in the other part A. Calculate the value of v prime of 14. You're still going to find just the slopes. For part A, you're still just talking about the slopes. So for A, you're still talking about slope. Figure it out. B, let's see what we got. Using correct units, explain the meaning of, this is one of the most important integrals in calculus, 0 to 50, I mean, those could be whatever, but the absolute value of v of t dt. Any ideas what that means?
Isn't it of the distance traveled, like all of it?
Yeah, bingo. All right, so let me tell you a story and we'll make sense of it. But yeah, you're correct. So, all right, here's a story. I think I told you this story before. Okay, this stands for snow fall over a period of time. If it snows 2 inches per hour for 3 hours consistently, that rate doesn't change. It's consistently snowing. It's not going up and down, consistent. The total amount, the area under the curve, and just common sense tells you if it snows 2 inches an hour for 3 hours, it's 6. Mathematically, though, the area of that box is 6. Likewise, what's the equation of that horizontal line? Hopefully you're saying y equals 2. Now that we know how to integrate, if I integrate 2 from 0 to 2, what does one get here? This would be 2x from 0 to 3. Plug in some bounds. I've got 6 minus 0. I've still got 6. Okay, so moral of the story. The areas under the curve stand for a total amount of something. Total amount of snowfall. Total amount of water. If it's velocity, that's a special one. If it's v of t and t, whatever that area is under there, when you integrate the velocity, the total velocity, that's standing for distance traveled. You should write this down and put a star by it. The integral of the absolute value. Why absolute value? Distance cannot be negative. The integral of the absolute value of v of t dt stands for distance traveled, total distance traveled. All right, very good. All right, back to the screen. All right, and in context of the problem, and then approximate the value using, this one says midpoint. Go ahead and scratch out midpoint. They don't ask you that on the AP exam. I think I made this problem up like 5 years ago, and I did not realize at that time that they didn't test midpoint. So call this, I don't know, whatever, a left-hand approximation. So do a left-hand approximation to estimate this here, which you now know stands for the total distance traveled. All right, part C. Don't know who Brian is because this problem talked about Jeff. They will just throw things at you in these problems. So somebody named Brian is riding his bike along the same path for 0 to t to 10. Brian's velocity is modeled by such and such. Find Brian's acceleration at 5. How do we find Brian's acceleration at 5? Somebody tell me the plan.
Take the derivative.
Yeah, because we got velocity, so I would just take a derivative and plug in 5. Bingo. D, based on the model in part C, find Brian's average velocity. How do we find average anything? We just talked about it. We need a formula.
1 over b.
1 over b minus a times the result of the thing I'm looking for. What's the thing I'm looking for? Average what? Average velocity. That means I want to do 1 over b minus a. That's 10 minus 0. That's 10. I want to do 1 over 10 integral of velocity. We have a formula. It's up here in part C. So you would take this formula up here, and that's your integration. So it's 1 over 10 integral that thing, and you've got bounds from 0 to 10. Do you guys feel like I've given you enough information that you can try both of these for homework and bring them to class tomorrow?
Absolutely.
Cool. That's all I got. So try these 2 problems tonight. you have to try these though. I know there's no grade book. I know I can't do anything to you if you don't do them. Try the problems is my best advice. This shouldn't take you any more than 20, 25 minutes to have both of these done. Try them, work on them, bring them tomorrow. It'll be the first thing we do in class tomorrow for about the first half hour. Okay. All right, guys. Have a good night. See you tomorrow.
Thank you, Mr. Baker.
All right. See
You
ya.
have a good night.
You got it. See ya.
Thank you, Mr. Baker. Bye.
You're welcome. See ya.